Okay guys, you should be writing these 6 trig identities down. These are our sum and difference identities. That's why they all say u plus v or u minus v. Shh, guys. We're going to be looking for the exact value. You're going to be looking at problems that have degrees, problems that have radians, and problems that are set up like we did last week, where you have something and you find something else. Now this one, we're trying to find the exact value of the cosine of 75 degrees. By exact value, I do not mean put it in your calculator and get a decimal. Exact value means these are going to come out with radicals and they're likely going to be fractions. Now, what makes 75 degrees difficult to find the exact value? The whole reason I'm changing 75 degrees into 45 plus 30 is because I know those reference angles. I know 45 degrees, I know 30 degrees. I can think about my unit circle and I can answer any of my trig functions for 45 and 30, but I can't answer my trig functions for 75 degrees. Now if we look back, I know I'm going to use the cosine of u plus v, and I know that formula goes cosine u sine v. Oops, I wrote the wrong thing. Formula goes cosine u cosine v minus sine u sine v. And you can look that up on your formulas there. What am I going to treat as my u? The 45, and my v is the 30. No, if you look at your cosine formula, cosine of u plus v, they're opposite. We said that 45 is going to be our u and 30 is going to be our v. So I'm going to fill in the cosine of 45 plus 30 equals cosine of what? 45 cosine of 30 minus sine of 45 sine of 30. All you have to do is look at your u's. Think about where a 45 degree angle is. 45 degrees in the middle of your first quadrant. Cosine is your x value, and that's square root 2 over 2. What's the cosine of 30? Square root 3 over 2. All right, minus, what's the sine of 45? Square root 2 over 2. And the sine of 30? 1/2. All right, I'm going to multiply my fractions. Now, when you multiply, remember, straight across the top, straight across the bottom. What's square root 2 times square root 3? Square root 6 over 2 times 2? 4. Minus the square root of 2 times 1? Square root 2. All right, square root 2 over what? 4. Now, you cannot add or subtract unlike radicals. I cannot take the square root of 6 minus the square root of 2 and make it the square root of 4. It's kind of like x minus y. You can't do it. You can multiply unlike radicals. You cannot add or subtract. So our answer is going to be square root 6 minus square root 2 all over 4. Now the sine of 7 pi over 12, is that a reference angle that we know? What's the first clue that that's not on the unit circle? It's over 12. We didn't have any angles on the unit circle that were over 12. Now, I need to find the sine of something plus something. It could be something minus something, but I'm going to go ahead and take a guess that if I'm trying to get 7, I'm going to have to add. Okay, let's try in 3 and 4. Let's say 3 pi plus 4 pi. Now, 3 and 4 add to give us 7, but those will only work if they're reference angles on the unit circle. What does 3 pi over 12 simplify to be? Pi over 4. That's on our unit circle. What does 4 pi over 12 simplify to be? Pi over 3. So what's going to be u? The letter u. Pi over 4. And that means v is my pi over 3. I'm going to rewrite my sine formula. The sine of u plus v equals sine u cosine v plus cosine u sine v. Using that trig identity, I'm going to find the sine of pi over 4 plus pi over 3. So that'll be the sine of what? Pi over 4. Cosine of pi over 3. Plus cosine pi over 4. Sine pi over 3. You see how the pi over 4 and the pi over 3 stay the same order all the time? U comes first, V comes second. All right, think on the unit circle. What's the sine of pi over 4?
It says square root 2.
Square root 2 over 2. What's the cosine of pi over 3? Pi over 3 is 1/2. Cosine of pi over 3 is 1/2. Plus, what's the cosine pi over 4? Square root 2 over 2. And the sine pi over 3? Square root 3 over 2. So if we multiply square root 2 over 2 times 1/2. Square root 2 over 4. Plus square root 6 over 4. And how can I do that?
Square root 2 plus 6, square root 6 over 4.
Square root 2 plus square root 6 all over 4. The tangent of 75 degrees. Now the first part's easy. I don't know 75 degrees. That exact reference angle is unfamiliar to me. What could I change it into? 30 plus 45. I'm going to put the 45 first. It doesn't really... Okay, so we're going to change it. What in the world? So we're going to change the tangent of 75 into the tangent of 45 degrees plus 30 degrees. Which one's going to be u? 45 degrees. Remember, your u comes first, your v comes second. All right, let me write down the tangent formula. The tangent of u plus v equals tan u plus tan v over 1 minus tan u times tan v. All right, let's start with the tangent of 45. 45 degrees, what's the y value? Square root 2 over 2. What's the x value? Square root 2 over 2. I'm going to show all the work on this first problem. I know some of it you could do in your head. All right, plus, I'm looking at 30 degrees now. What's the y value at 30 degrees? 1/2 over square root 3 over 2. All right, and then we have all of this over 1 minus the tangent of 45 again. So that was square root 2 over 2 over square root 2 over 2 times the tangent of 30 again. So that was 1/2 over square root 3 over 2. What's the square root 2 over 2 over square root 2 over 2? 1. Okay, so that simplifies to be just 1 plus, almost. Does anyone remember what that simplifies to be? Or should we work it out? It's going to be square root 3 over 3. Let me work it out down at the bottom. Remember, keep the top fraction, change to multiplication, flip the bottom. So we'd get 1 over the square root of 3. Rationalize it. And so we get square root 3 over 3. That's for the 1/2 over square root 3 over 2. We get square root 3 over 3. On the bottom, we had 1 minus, that was there already, part of the formula. Square root 2 over 2 over square root 2 over 2. 1 times square root 3 over 3.
Will that end up making it just square root 3 over 3?
The 1 times square root 3 is just square root 3 over 3. So we have 1 plus square root 3 over 3 over 1 minus square root 3 over 3. Those do not cancel. You cannot cancel anything out there. I warn you not to get cancel happy here.
How did you do that?
What you were just telling me. 1 times square root 3 over 3 is just square root 3 over 3.
No, I was thinking.
Okay. Now, if we are going to simplify it, we have to treat it like any other fraction. Keep, change, flip. So I'm going to keep the top. Actually, I have one more step before that. Can I add 1 plus square root 3 over 3? What if they had a common denominator? What would it be? 3. What would I change 1 into? 3 over 3.
It would be 3 square root 3 over 3.
So it would be 3 plus square root 3 over 3.
Plus?
Okay? We're saying that 1 is going to change into 3 over 3. So what would the bottom be?
3 over, wait.
So 3 minus square root 3 over 3. I'm going to keep the top fraction. Change to multiplication. Flip the bottom fraction. When I do that, those single 3's cancel out. And I've got 3 plus square root 3 over 3 minus square root 3. You still cannot get cancel happy here. We're going to multiply by 3 plus the square root of 3. The bottom was 3 minus root 3. In order to get rid of it, I have to multiply 3 plus square root 3. I have to multiply it out just like FOIL. I'm going to have to do it down below here. Alright, first, 3 times 3, 9. Outer, 3 times the square root of 3. 3 square root 3. Inner, square root 3 times 3. 3 square root 3. Last, square root 3 times square root 3 is just 3. Okay, on the bottom. The bottom. First, we've got 3 times 3. 9. Outer, 3 times the square root of 3. 3 square root 3. Inner, I have negative root 3 times 3. That would be negative 3 root 3. No, because you had 2 positives. And last, I've got negative root 3 times root 3, which is negative 3, because I have a negative times a positive. So really, what do I have in the denominator? 9 minus 3 is 6. In the numerator, I've got a 9 plus 3. That's 12. And I've got a 3 root 3 plus 3 root 3. 6 root 3. That simplifies. What's 12 over 6? 2. I'm going to write it up above there. What's 6 over 6? 1. So I have 2 plus 1 square root 3. Box in my answer because I had to go up. B. So I need to take my information about U and get my missing pieces, and take my information about V and get my missing pieces. Now, what do I know about U? I know the sine equals 4/5. What don't I know about U? The cosine. So let's use our formula from last week. The cosine squared of U, because I'm talking about U, plus the sine squared, so 4/5 squared, equals 1. What's 4/5 squared? 16/25, and I'm going to subtract that. What do I get when I take 1 minus 16/25? 9 over 25, so the cosine squared of U equals 9 over 25. What does that make the cosine? 3/5. Now, go back and check your quadrant. U is between 0 and pi over 2. What does that tell us? First quadrant, so is the cosine positive or negative? Positive. Okay? Now let's worry about V. What do I know about V? For the V, I have the cosine. What do I need for the V? It's the sine. Okay, now I know that the cosine of V is negative 12/13, and I'm going to square that, plus the sine squared of V equals 1. What's 12/13 squared?
144 and 1.
So 144 over 169, and I know I'm going to subtract it. What do I get when I do 1 minus 144 over 169? What's 169 minus 144? 25. So I get 25 over 169. So what's the sine of V? 5 over 13. I need to check on my other quadrant. V is between pi over 2 and pi. What quadrant is that? The second. Pi over 2 and pi, that's the second quadrant. Is my sine positive or negative in the second quadrant? Positive. Okay, so we've got all the right answers. Now we're going to go back and do the sine of U plus V. Remember the formula, sine of U plus V equals sine U cosine V plus cosine U sine V. What's the sine of u? You've got it. The sine of u.
4/5.
4/5. What's the cosine of v? Negative 12/13. Plus, what's the cosine of u? 3/5. Times, what's the sine of v? 5/13. You can type that whole long string into your calculator. I'm going to go ahead and give you the answer for the sake of time. We get negative 33 over 65. The homework problem here is not asking you to solve anything. You just have to simplify it using the formulas that I just showed you. If you do it correctly, the left side of the equation will match the right side, and that's how you prove it. You notice on the left side you have the sine of u plus v, and you would do that formula, and the sine of u minus v, and you would do that formula. It works out really nice and neatly. It is not a trick. It's not meant to be hard. You just have to think of it a different way.